Hi, in this video we are going to talk about normal distribution, z-scores and percentiles. So we're assuming that by now you're familiar with the 68, 95, 99.7 rule. So here's an example. You have a particular small engine with mean life of 6,000 hours and standard deviation of 800. The engine's lives are normally distributed. Find the percentage of engines between 6,000 and 7,200. So here's our problem. If you calculate, if you look at 7,200, that's not a full number of standard deviations above the mean. You get 1,200 and the standard deviation is 800, so it's some sort of a decimal. And we cannot use 68, 95, 99.7 rule. So we have something called z-scores. And to calculate the z-score of a data item, we use the following formula, which is right here. So you take the data item minus the mean and divide it by the standard deviation. And z-score is going to show exactly how many standard deviations above, if the z-score is positive, or below, if it's negative, the mean is going to be. So to connect it to the rule that you should know, 68, 95, 99.7, we're going to go back to that previous example. So if you take engine life of 6800, it is one standard deviation above the mean, and it's going to be 6800 minus 6000 divided by 800, and the z-score is positive 1. If you're looking at 3600, it's 3 standard deviations below the mean. 3600 minus 6000 divided by 800 is going to give you negative 3. So here's your connection between z-scores and that rule that you already know. Let's go ahead and take a look at some examples. So particular normal distribution has a mean of 40 and standard deviation of 8. Find z-scores for all of these specific items. So here's all you need to do. The z-score here is going to be 44 minus 40 divided by 8. Do the math here. It's going to give us 0.5. So that means it's half a standard deviation above the mean. With 30, the z-score is going to be 30 minus 40 divided by 8, which is going to give us negative 1.25. For 52, 52 minus 40 divided by 8, which is going to be 1.5. The z-score here is going to be 72 minus 40 divided by 8, which is going to give us 4. So that means this value is 4 standard deviations above the mean. And finally for 20, 20 minus 40 divided by 8, which is going to give us negative 2.5. So finding z-scores is easy, as you can see. Alright, how about going the other way? So if you're given the z-score, what value does that z-score correspond to? For that, we pretty much use the same formula. We're just going to have to set it up as an equation and solve it. So this is how I always do it. You're going to have 0.5 equals, so we have a mean of 64 and standard deviation of 10. So we don't know the data item, which is what we're looking for, so that's going to be x minus 64 divided by 10. So we multiply both sides by 10, we get x minus 64 equals 5, and then from here we can see that x is going to equal 69. Alright? So proceed in the same fashion. Negative 1.2 equals x minus 64 divided by 10. Multiply both sides by 10, you have x minus 64 equals negative 12, and that's going to give you x equals 52. Negative 3.6 equals x minus 64 divided by 10, which gives us x minus 64 equals negative 36, and x is going to be 28. 2.1 equals x minus 64 divided by 10. So x minus 64 equals 21. And that means that x equals 85. And lastly, negative 0.4 equals x minus 64 over 10. Let's by both sides by 10. So we're going to have x minus 64 equals negative 4 and x equals 16. Okay, that should be pretty easy too. So now we're going to talk about something called percentile. So what's a percentile? Percentile is a percentage of data items with values that are below a specific data item. So just to demonstrate, so if you have this normal distribution here and you're looking at this, there is some kind of a data item that corresponds to that. Let's call it M. So when we say that this number is in the 90th percentile, that means that 90% of the other items are going to be located below this value. Just to give you an idea, if you take some kind of a test, for example, in the United States, you might be taking like SAT or ACT, and you get your score report and it says you scored in the 85th percentile. That means that 85% of people who took the test with you scored lower than you. And also please remember that the terms percentage and percentile are not interchangeable terms, so they cannot ever be used to replace for one to replace the other. All right, so this is a fairly challenging, well, it's not actually a challenging thing, it's a table that you actually don't have to memorize, but this is what you need to know for z-scores. That's called a z-score table. It comes in multiple variations when you have different precision in the table, sometimes just for the positive side, for the negative side. We're really just going to focus on how to use that. We're not going to get into details. Basically what it tells you, it shows you a percentile for each particular z-score. So just to give you an idea, for example, if you have a z-score of 1, which means a particular value is going to be one standard deviation above the mean, the percentile that corresponds to that is 84.13. Okay, so obviously the higher you go with the z-score, the higher the percentile gets. The lower you go, the lower it gets. Okay, so we're going to refer to this for the rest of this worksheet. So to find, we need to learn several things. How do you find percentage of items below a certain value? This is actually the easiest thing to do. To find percentage of items below a certain value, we find the z-score for the value, and then we find the z-score for using z-score table. We find the corresponding percentile, and that is going to be exactly the same as the percentage. The length of human pregnancies are normally distributed. Its mean is 266 days and the standard deviation is 16. So what percentage of human pregnancies last less than 290 days? The first thing we need to do is find the z-score. Let me go back to my brown marker. So z-score is going to be 290. So 290 minus 266 divided by 16, which is going to give us 1.5. Okay, so with 1.5 we're going to go to the z-score table. We're going to find 1.5 here, which is right here. It's 1.5, so that corresponds to 93.32 percentile, which means that's how many items are going to be located below that value. So in this case it is 93.32. 93.32%. What percentage of human pregnancies last less than 226 days? So we start by finding the z-score. 226 minus 266 divided by 16. That is going to give us negative 2.5. So this value of 226 is negative 2.5 standard deviations below the mean. So we need our z-score table. Negative 2.5 is right here. And the percentile that corresponds to that is 0.62. So the number of items below that is 0.62, 0.62%. right? How do you do it for a percentage of items above a certain value? That's not too hard either. So you find the z-score for the given item, you find the corresponding percentile from the z-score table, that's the percentage of items below, so the percentage of items above will be 100 minus that number from step 2. Example 4. Scores on the law school admission test, LSAT, are normally distributed with a mean of 150 and a standard deviation of 10. What percentage of LSAT takers score above 168? So we start by finding the z-score. So the z-score here is going to be, what do we have? We have 168, so 168 minus 150 divided by 10. That is going to give us what is this here? 160, 1.16 divided by 1.6, right? No, I'm sorry, 1.8. I had the wrong number on my solution accidentally, right? So we have 168 minus 150, that's 18. 18 divided by 10 is 1.8, right? So what we need to do now is look at the z-score table. So for 1.8, we have 96.41. So that's 96.41. That's the percentage of those who scored below that, right? So 96.41% scored below. So 100 minus 96.41 will give us, that's going to give us what, 3.59 scored above. Okay, so all you need to do is do 100 minus 10 will give you the number above, the percentage above. Okay, below, how many scored above 127? So the z-score, 127 minus 150 divided by 10. That's going to give us negative 2.3. So this value is negative 2.3 standard deviations below the mean. So I'm going to go to the z-score table, negative 2.3. Negative 2.3 corresponds to 1.07. So our answer will be 100 minus 1.07, which is going to give you 98.93% above. Okay. The most challenging question is when you need to find the percentage of items between two values. So you're going to have one value, another value, and you want to find what percentage of items is going to fall between them. So you're going to find the z-score for each of the items. You're going to find the corresponding percentile for each given value. And then the percentage between will be the higher percentile minus the lower percentile. You basically find the difference between them. Okay. But the challenge here is you have to find two z-scores and two corresponding percentiles. So let's go ahead and start with this. So 68. So for 68, the z-score is going to be 68 minus 75 divided by 5, which is going to be negative 1.4. And for that, for negative 1.4, the percentile is 8.08. So 8.08. So for the second value of 79, the z-score is going to be 79 minus 75 divided by 5, which is giving us 0.8. And for 0.8 z-score, 0.8 percentile is 78.81 right here. Okay, so our answer is going to be 78.81 minus 88.08, which is going to give us 70.73% between. Okay. This one, between 77 and 89. So for 77, the z-score is going to be, it's going to be 77 minus 75 divided by 5, which is going to be 0.4. For 89, sorry, the z-score is going to be 89 minus 75 divided by 5, which is going to be 2.8. So for 0.4, from the z-score table, for 0.4 it's 65.54. 65.54. For 2.8 it's 99.74. And our answer is going to be 99.74 minus 65.54, which is going to give us 34.2% between. Okay. And I got one more example here where we do a little bit of each. So we have weights of apples harvested by a farmer are normally distributed with the mean of 120 gram and a standard deviation of 20. So what percentage of apples weigh less than 82 gram? So we start by finding z-score. So 82 minus 120 divided by standard deviation, which is 20. So here we have our z-score of negative 1.9. This is less, so below a value, we're going to get our percentile. That's going to be the answer. Negative 1.9 is here, corresponds to 2.87 percentile, and the answer is 2.87%. What percentage of apples weigh more than 152? So we start by finding z-score. 152 minus 120 divided by 20. So that's going to be 1.6. So for 1.6, the percentile is 94.52. So for this one's 94.52, but we want to find above, so right, more than, so we're going to do a 100 minus 94.52, which is going to give us 5.48% above. And finally, what percentage of apples weigh between 98 and 126? So we need to find two z-scores. For 98, the z-score is going to be 98 minus 120 divided by 20, which is going to be negative 1.1. For 126, the z-score is going to be 126 minus 120 divided by 20, which is going to be 0.3. So for negative 1.1, the z-score that z-score corresponds to percentile of 13.57. For 0.3, 61.79. And to find the percentage between, we find the difference. 61.79 minus 13.57. That's going to give us 48.22% between. Okay, and that's all.